back to Housebuild TV. Tonight we're going to touch on part A. I would like to welcome back Geoff Wilkinson from Wilkinson Construction and my co-host Eoghain Ryan from Ryan & Associates and housebuild.co.uk. Thank you for joining us this evening, Geoff, and feel free to kickstart part A for us.
Yeah, pleasure as ever. Yeah, so it's, as you know, we're going to be running through the alphabet of building regs. So where better to start with than part A? That seems to be a logical start point, doesn't it? And where within part A should we start? Well, let's start at the bottom and work our way up. Let's start talking about foundations, for example. Where should we look at? So one of the first things when you're designing your building, etc., is to make sure your foundation's right, obviously. And the first thing to think about there is what the soil type is going to be. So if you haven't already undertaken some form of soil investigation, will help you determine what kind of foundations you're going to be using for the building. Now, first thing I suppose I should really mention about part A itself is it's really intended for typical small scale buildings. Okay, so if you're looking to build a 20-story block of flats, this is probably not the place to start looking in the first instance. This really is primarily intended for kind of your typical basic developments. So having taken a look at what type of soil you've got, the stuff in part A will actually give you some sort of minimum depths for foundations, depending upon the type of soil that you've actually got. Anyone want to hazard a guess at what the minimum depth of a foundation is?
600 mil.
Okay. One of the things that is quite interesting is that if you actually look at most architects' drawings, they tend to turn around and say that the minimum foundation depth will be 1 meter deep, and to the satisfaction of the building inspector. When you actually go to the regs themselves, they don't quite say that at all. When you're actually looking at them, you need to have a minimum depth that is not going to be affected by frost heave. 600 would be fine. So it's not necessarily the case that you're going to need to have a foundation that's 1 meter deep. But equally, depending on the type of soil that you've got, you may end up with a much deeper foundation. Typical example of that is if you've got a clay soil. If you've got clay soil and you've got trees, for example. Now, in that set of circumstances, you'd be looking to check on the distance that the trees are from the foundation that you've got. And if the tree is within its mature height from the foundation itself, then it's likely that you're going to have to go down deeper. And there are a set of tables that building inspectors use to determine the suitable depth of those foundations. So that's sort of one immediate tip we can give you to start off with, to make sure that your starting off point is to make sure that the foundation depth is actually going to be adequate and that you've allowed for it. That's for sort of a traditional strip foundation. You do have other options as well. You have raft foundations, you have piled foundations, and you have a variety of specialist foundations out there as well. So there's a variety of things that you could consider as being the option for your particular building.
Geoff, in the UK, are you seeing more of a change towards raft foundations, or to more like there's the likes of Core and some companies have their own specialist thermal foundations, raft foundations, strip foundations, which have zero thermal bridging? Have you seen a shift towards that over the last, particularly with the new Part L coming through? Are people looking at changing their foundations, or is traditional foundation still there?
It depends very much. If you are talking about the new build market, we are certainly seeing a lot of eco homes, a lot of passive house, where the point that you're making about the raft foundation and the thermal properties of it are very important to that style of development. But I would say that probably about 80% of projects that we deal with are just bog standard traditional strip foundations that builders know, love, and are competent in doing. The problem obviously is that the more complex or unusual the foundation design, the more information that you need early on, and the more experience you need in dealing with that type of foundation. So it's gradually coming, and certainly as each step in the changes to Part L kicks in, and as we move ever towards zero carbon housing, we're going to see that more and more.
Yeah, no, I've seen a shift in Ireland to it, and it's just it's good to see. But again, a lot of people just go back to strip foundation or the raft foundation. We have a very in the west of Ireland particularly, you have a lot of limestone, so digging a strip foundation is not essentially practical. So raft foundations are very common. So, but they wouldn't be in the likes of the UK, where you have better soil and better land than we have here in poor old Ireland. But sure, look,
yeah,
have to get on with it.
So the majority of projects are likely to have a structural engineering board, or structural engineer on board even. The structural engineer will be responsible for the majority of the design of the building. They'll start working through the loadings from the roof, calculating it all the way down the building and down to the foundation itself. Part A, however, does cover a whole series of sort of typical recommendations. Now, they could be typical sort of small single-story extensions, that kind of stuff. And it gives you some guidance on ratios, for example, between the height of the building and the thickness of the wall that you're proposing to have. So that would be one of the parts of the regs that you might want to be looking at if you're determining how high your building is going to be in relation to the thickness of the wall that you've got. It also covers things like the proportions of any openings that you may have. So you may want to, as the trend very much is at the moment, to have large areas of glass. Now, if you're having large areas of glass, it means that the actual leftover amount of structure is actually quite small. And you need to have a proportion or a ratio of structure to opening. Otherwise, all you've got is opening, and the opening's not going to hold an enormous amount up. And you end up with what is effectively just a framed building rather than a traditional constructed building. Now, there are ways around that, and a structural engineer could design things like wind posts, etc., into the building itself to help the structural design of the building to maintain its structural integrity. But beyond that, you want to make sure that there are minimum sizes for the returns. So that's the bit of wall at the end of the building, and how it functions back against things like windows, door openings, etc. So there are proportions and ratios that you need to be taking a look at. And there are some quite sort of handy tables and guides that it might be worth taking a look at. For example, if you go to diagram 4, it gives you the maximum height of a parapet wall, for example. So a parapet wall, in case anyone's unfamiliar with the term, a parapet wall is the bit that sticks above the roof. So particularly in a sort of traditional building, you'd have a roof that comes in and then a bit of the wall that sticks up, typically between houses as well. A lot of the traditional buildings used to have a party wall that comes up through the roof and sits there on its own. So there's guidance to say in diagram 4 that gives you the ratio of the thickness of the brickwork and the height that you can actually have that wall. So for example, it gives you for a thickness of 150 millimeters, a maximum height of 600 millimeters. So you can see the ratios that you're then going to be allowed to do. Obviously, the higher that you take the wall up without any further support to it, the less stable the thing becomes, and particularly the effects of wind that can be had on that. So that's quite a useful guide that you can use. There are also guides to where you are within the UK and the maximum wind speeds that you're likely to be facing. And that's going to be quite important depending on where you are, because that will have an effect on the amount of loads that are put onto your building. So just because you've designed something sort of in central London, if you're then going to be going up into a very exposed part of the country, you may well find that some of the ratios that you are used to using won't actually work in the more exposed areas. So
that limits to the level at which you can build above ground as well, if on the side of a hill, and the exposure of that. And people, you know, it makes sense when you talk through it like that, is particularly like, you know, you're talking about parapets. If you have a parapet that's not fully structurally loaded properly, and it's on an elevated site, that parapet will come down very quickly. So there's reasons behind all of this, and the studies have been done there to ensure that houses and structures are built safely.
Absolutely. And another one that sort of gets all of the headlines every time there's a storm or anything is the inadequate design of gable walls. So the gable wall, for people who are unsure, it's sort of the bit typically that's in the triangle at the top of the exposed flank. And what often happens there is that if the restraint isn't in place, as wind passes alongside it, it will literally suck the brickwork out. And there have been examples of it on TV where there's a car parked underneath and the entire gable end has been sucked out by the wind and landed and crushed the car. So there's some important detailing on there, and that's something that we find builders often get wrong. So it might be worth taking a look in particular at that example of the detailing in the approved document. Maybe on the video afterwards we can bring that up specifically so that people can look at it. What we often see is that the straps, so that's what we would typically refer to as an L strap, which is basically a long length of strap in an L shape. So you've got a long leg there and a short leg there. And what often happens is that's just screwed into the end of the gable end and is just screw fixed to the rafters themselves. Now it needs to be solidly nogged and it needs to be built in properly to ensure that the suction doesn't end up just pulling it out of what is often just a screw hole into the end of the brickwork.
Well, not a nice story, but I worked on an apartment block which was 6 stories. And they had an apex roof on it with like an attic void, but there was actually it was built in the peak boom of our Celtic Tiger, and it actually had no roof straps. So
none at all. So not even badly built, none at all.
None at all. Subsequently, 7 years later, the roof comes flying off in a storm, and it's not a very exposed area. It just shows you any kind of wind loading can take it off. Like, and you would think from the outside it's structurally fine, everything's fine, but if a roof's not strapped down, it's essentially like a hat on an old man walking down a prom on a windy day. It'll blow off.
Absolutely. So just to clarify for anyone listening, so not only are we strapping the ends of the brickwork to the roof to support the brickwork, we're also strapping the roof down to the brickwork to prevent the entire roof coming off on its own as well. And it's important to make sure that you're doing that. Now, an example of the detailing for that is in diagram 16 in the approved document. So you can take a look at diagram 16 there, which gives you examples of those L-shaped straps and the kind of examples of distances that you need to have them. Typically, we'd expect to see them about 1.82 meters apart, working their way up the ridge line of the building. So it gives you an idea of the importance of that. Another example that we often see is that garages are an example of this, where people overextend the double garage door, if you like. They don't have an intermediate pier in the middle. And then they stick the garage door onto the beam that goes above. And we've had examples there where the torsion that's on the structural beam, which sometimes is even just a lintel, is such that it turns the entire lintel and effectively almost snaps the lintel, or just brings the brickwork out, because it's sufficient force over that length to twist the entire beam or lintel in place.
And that's like the lintel's already under pressure from what's it's holding above, let alone being pulled from below. So it's like these are like what you would think would be caught at a design stage, but it happens too often.
A lot of the time it's not designed. I think that's where a lot of the problems actually start from, that people will have simply got a fairly simple copy of the load span tables off of one of the well-known manufacturers, and they'll go, oh, we'll stick one of those in, and just assume that it's done without any real thought to what the loadings might be. So there are a couple of examples that I can think of immediately within Part A. There are also guides to wall cladding, for example, and the fixings of the cladding, and the need for an assessment of the wind loading on the cladding. Now, again, that's something that we see more so on sort of blocks of flats, that kind of thing, rather than simple dwelling houses. But a lot of the time, no real thought is given to the fixings themselves. So you might have cladding rails, and then the cladding is fixed to the cladding rail. And what can again happen is that the wind speeds are such that it literally strips the cladding straight off, because the fixings themselves have not been checked to see whether they will pull out. So it's what we refer to as a pull-out check, which is something that you should really undertake to make sure that your fixings are actually solid and in place. Whilst I'm on that one, it's also worth mentioning about Juliet balconies. They're really sort of on trend. So for anyone that's not quite sure, a Juliet balcony typically is where you have a set of like French doors, but at first floor level. And then you have a piece of glass or balustrade that's fixed back to the main facade of the building that prevents you falling out of it when you open it out. Again, something that's very sort of on trend at the moment. We're seeing a lot of those, but people literally screw them back to the wall rather than thinking this is a major load bearing element. And if you've got two people leaning against the thing, that's quite a substantial amount of force that's being put on it. And sometimes they're literally just screwed in, or they're bolted back to a piece of timber, and the timber's not been checked, it's split, and before you know it, you could end up with a structural failure coming from those.
Yeah, like the thing, like the Juliet balcony comes from, people don't know this, it's from Romeo and Juliet, when Romeo was serenading Juliet on the balcony, and she was, but like people have to, that brings in parquet and guarding, but there's no point having guarding if the structure is going to fall off, you're going to fall anyway. So like they are becoming very popular, particularly in new developments and like apartment blocks where they want to give some kind of open area or some kind of like viewing area from apartments. But yeah, no, it's common across a lot of areas, and we've noticed that ourselves.
Absolutely. So if we move on to sort of the next section in the regs, it actually then goes on to re-roofing. Now, re-roofing itself is quite a common improvement project. If you've got a house that's got a roof that's 25 years or more old, it's probably going to start having some kind of risk of leaking or damage coming to it. I remember well my time served with local authorities in an East London borough, where the builders would come out on a Friday night, pick on whoever they could to turn around and say, your roof's in a bit of a state, love. You need to get that replaced. I'm free over the weekend. I'll get that done for you. And off would come the slates, and on would go the concrete tiles, and they'd be away by Monday before the inspectors were back out and on patrol again, if you like. The problem with that, apart from the fact that they're dodgy cowboy builders in the first instance, is that when you're doing that, there's a very substantial load difference between the original slates and the proposed concrete tiles. So what you need to do in those circumstances is put additional strengthening into the roof. So you might have to put struts to hold the purlins up in place. You might have to put an extra purlin in. You might have to put collars or ties to stop the roof spreading. under all of this additional load. So that's something that we would again say to people, be very wary of if someone's offering to come round and do some re-roofing works. Make sure that it's been designed properly and that someone's inspecting it.
I haven't heard of that now, but they're good chancers anyway.
Absolutely, absolutely. But then the next section in part A actually is an even more serious concern, and one that isn't so much to do with your small builders. It's to do with what's referred to as disproportionate collapse. Now, for those of us that are old enough, there was a building in London called Ronan Point. Ronan Point was a big tower block that had been built during the post-war era, and during that they typically used what's known as large concrete panels. So the building was effectively a series of large concrete panels and hadn't been fully tied together properly. There was a gas explosion in that building, and as a result of that, one of the major sections was literally blown out of the building. That caused the majority of the building to collapse like a pack of cards. We've seen that in recent weeks with the earthquakes, and we've seen it in the United States as well. So there's a specific regulation that deals with larger scale buildings, so that in the event that one of the core structural elements fails, that you don't end up with this kind of pack of cards effect of the structure falling down upon itself and collapsing in. So depending upon the type of building you've got will affect whether or not this applies. One of the projects that we're seeing quite a lot of at the moment, because of the changes to the planning regulations, is people wanting to extend and put another story or 2 stories on top of an existing building, and this can often be on an existing block of flats, for example. So if you're adding all of this extra load and weight, you need to consider what would happen if one of the walls or beams or columns in the lower section were to fail. Is there a risk of the whole lot collapsing in on itself? And there's some specific guidance within section 5 of approved document A that helps to explain all of that and where you've got those particular situations.
Yeah, obviously in that situation you have to have a key structural design engineer on board, and all loadings would have to be taken into account. But like, it is critical, like, it's, people cannot ignore that fact, and it's, you have to, you know, obviously that's going through building controls. So the chances of that in this day and age shouldn't happen, but we've all seen and lived from experience that, you know, history repeats itself.
Absolutely. So I say it's important that that's done. Now, previous versions, if you go back in time, previous versions of Part A used to have a whole series of really helpful tables at the back of them, known as timber span tables. And what those tables used to do was tell you what size joist you needed for a particular span. So if you had a flat roof, for example, and it was 3 meters clear span, it would tell you what size and spacings each of the timbers would actually need to be. That was taken out several years ago from the document because it wasn't being kept up to date with the changes to the structural timber market. But they used to be really, really helpful guides, and you can still obtain copies of those timber tables from an organization called TRADA. But that's the Timber Research and Development Association, but they are an extra paid resource that you then have to go out and get rather than the handy updated version that you used to have within Part A. So that's sort of been a quick whistle-stop tour. Anything in particular you'd like to ask?
Just in regards to what I've noticed on housing developments, where you're just talking about joists, it's very timber joists, and the sizing of them, like generally you're looking at a 9x2 or a 7x2, but they've gone from timber strength C18s to C24s, and that seems to be the standard that they're looking at now, rather than back in the day. You know, you'd have a lesser standard, and it's all stemming from Part A. And I'm just wondering, is that the same in the UK? Are people looking at C24s, or what are they looking at?
We're actually seeing slightly different trends to that. So what I would say we're typically seeing these days are what we refer to as a greater use of engineered joists. Now, an engineered joist, so a traditional timber joist is just a solid piece of timber, 9 inches deep, for example, and 2 or 3 inches across. Instead of that, what you're now seeing is effectively like a laminate piece in the middle, and a piece top and bottom. So you're effectively having like a structural eye timber.
Yeah, a posi joist.
A posi joist, if you want it. Yeah.
Go on. Sorry.
Yeah, or alternatively, you can have versions where you have like metal work in between the joists. The advantage of using that style of structural member is that it gives you zones that you can run your services through, so that it makes life a lot easier for everyone coming, all the trades subsequently, to actually run the services through, because you've already got pre-created joists, gaps for you to run it through. If you're using your traditional timber joists, then there are specific regulations about how much of that you can cut away. So it depends on the location, whether you're towards the end of the span or whether you're in the middle of the span, and there are requirements in relation to the amount that you can notch out and the amount that you can drill a hole through. I've seen examples where builders have cored 4-inch soil and vent pipe straight the way through the joist, and you've got like 1 inch of timber either side of the thing, and then they're wondering why it's not quite holding up as it should have done. There's a bit of bounce in the floor going on, or you're seeing a bit of a dip in there. There might be a reason why that is. So it's worth bearing in mind that you need to work out where your services are going to go and how much of those joists you're actually going to have to cut out to do it. So that's why the posi joists or the structural engineered joists would be potentially a much better option for you.
Yeah, and going back to, they allow you greater spans. That's the thing. They allow you to have greater opes and greater distances between walls.
Yeah.
The one thing that, and we'll discuss it probably in our next HBTV series, is the likes of posi joists introduce fire risk because it's open web joists.
Yeah.
And when you have a normal traditional joist, it's a full thick structure that sort of prevents smoke and fire pass through readily, whereas open web joists, as they're known, allows better services, better spans, but can affect the build in terms of fire safety. So there's a lot more onus on protecting the services as they come in and out of those floor ceiling combinations. So like, it's like, Geoff, that was a brilliant synopsis of Part A from start to finish, and you ticked all the boxes there, and thanks a million for that. And I'm sure now we'll get into more depth now when it comes to Part B, which is the scary one for most people.
Yeah, I think we're probably going to need a couple of episodes on Part B, to say the least. So yeah, look forward to that, and tune back in coming weeks to find out more.